Okay.
Okay. All right, good deal. Now, that's why we do that. You say name more attentive.
Okay.
Go ahead, you start.
All right. So we have a number of folks that are in the webinar right now, and we'll go ahead and get started. So I wanted to welcome everybody to this expert session to look at issues in the code related to the use of plastic ducts. And all of you who are on the webinar right now had received an invitation from me. This is Ari Rapport at Ibicus. That included an invitation to join us for this session, but also to be part of an expert working group. And we'll talk a little bit more about that later in the webinar. But I just wanted to let you guys know that this session really is there to provide the background information for further participation. Speaking today, we have 3 panelists. We have Anthony Grizzolia. He's a director of our product innovation team at Ibicus. Myself, Ari Rapport, I'm a program manager at Ibicus. And then we have Pam Cole, who's a research scientist at Pacific Northwest National Laboratory. She focuses a lot on code issues, related to residential buildings, commercial buildings, and particularly related to energy use. So before we get into the material, just a couple housekeeping items. What we have is a bit of a presentation up front that we want to share with you to provide you with some background information on this issue. Throughout the presentation, you folks may have questions that you want to ask of us. To do that, you'll see in your viewer window for the GoToWebinar the opportunity to type in those questions, and we have someone here who will share those questions with us. We may, depending on how we're moving through the slides, be able to stop and take those questions where we are, or we may decide to wait till we get toward the end of our presentation. We'll have some time at the end of this webinar to address those Q&As. If we have time after addressing any questions that people submit through the box there, the window, we'll open up the mics so that we can have a more sort of verbal interaction around any other questions or discussion points.
And if we don't get to answer all the questions, we will respond to you directly.
Right, and if you raise your hand for the verbal part, if they have time and you raise your hand by clicking on that little hand icon or something that will look like that roughly on your setup, we will turn around and unmute you. You're going to need to put in the code that you see that will allow you to speak. So we'll have to turn you on and off, and if they do that, they'll prompt you at that point in time as well.
Yep. Okay, so to start this off, I want to talk just a little bit about why you folks are here, why we invited you to be part of this session, to be part of the working group. And really, the goal is to raise awareness within the code body, the code officials, around an issue that has been identified around in the IRC, in the International Residential Code, related to plastic ducts, specifically around the use of plastic materials for duct systems. We want to be able, through this working group, to explore possible solutions to this issue that's been identified, to get your feedback, and have a venue for ongoing participation towards a solution, which could involve a code change proposal at some point in the future. For today, for the agenda today, we're going to spend just a few minutes up front kind of introducing the topic, talk a little bit about why this is important for the residential building community, and why this matters. We'll talk a little bit about how plastic ducts are currently being addressed in the codes. We'll share with you some of the current work that's been done to date on our end and with Department of Energy. And then we'll discuss the path forward. So where do we go from here? How do you guys stay involved and engaged in this effort towards identifying a solution, along with the timeline? We're anticipating that our presentation will last about 40 minutes. If we can make it go faster than that, we will. And then the remainder of the time we'll spend on Q&A. Again, that may provide opportunity for live discussion, but we'll see how things go and where we are at the end. We also had given everybody a questionnaire. I hope everybody received that email and attachment. So we'll talk about what we want you guys to do related to that. So by way of introduction, I want to talk about what the relevance of this issue is. Because this is a part of a project right now funded by the Department of Energy's Building America program, there is a very close tie-in to their strategy, to their roadmap related to optimal comfort systems, which really has to do with space conditioning and HVAC systems. Also, Ibicus is a company, we're located in Pittsburgh. We have a history of doing housing research with Department of Energy and on our own, and looking at comfort systems, looking at air distribution systems has been an ongoing part of our research effort. Also, there are a number of issues that are facing the industry today that tie into why this issue of plastic ducts has relevance, and we'll discuss those as well in the presentation. Sorry. Okay, so our focus really, just to give you a broader view of what we're looking at when we talk about plastic ducts in homes, we're really talking about conditioned supply air systems. These are above ground duct systems located in detached or attached 1 or 2 family dwellings that are 3 stories or less, really low-rise residential buildings. By ductwork, we're referring to the pathway between the conditioning equipment, the furnace, air conditioner, heat pump, and a particular room. The ducts that we're talking about refer to the continuous runs, and then the fittings are the components that are used to connect ducts. So just to give you that broader overview. So I'm going to kick it over to Anthony here to get to the next section, which really is about why this issue is important.
So, yeah, so one of the big things that we're seeing as Ibicus and looking at where the industry is today and where we're forecasting, there's a lot of trends going on. And at a high level, we're seeing lower load homes being adopted day in, day out. There's a lot of challenges in the industry among itself, but also in the HVAC world. And then lastly, the advantage of plastic ducts and really how it could help these future forecasts and challenges. So if we look at lower load homes, there's obviously, you guys are pretty aware of all the energy code adoptions over the last 10 years and all the states, now going forward with 09, 12, and now future 2015 codes. So buildings are required to conserve more energy. And the states are, aggressively trying to adopt these new codes. So if we look at lower load homes, so what's causing lower load homes? Well, energy codes are pushing it, and homes are being insulated higher. So insulation in the walls, roofs, and foundations, R values are increasing. We're seeing a new addition to continuous insulation on the outside of wall systems, which therefore is requiring thicker insulation on the outside, but ultimately it's creating smaller heating and cooling loads. And with that, the indoor loads, whether it's heating and cooling, are getting a lot smaller. So if we look at lower load homes, we're looking for the need for manufacturers to develop small capacity heating and cooling equipment. And those big manufacturers have been slow to get into this process of creating small capacity equipment. But we're starting to see companies like in Canada creating some small gas furnaces, and also the ducted mini split technology is coming to market slowly, but it is. But we're looking at ducts. So with small capacity equipment, when we're getting into loads of 15,000 BTUs of heating and a ton and a half of cooling, we're not required to install large ducts anymore. We're required to install smaller ducts. So our traditional size of 6 to 8 inch branch runs are now going down to 2.5 to 3 inch runs. So the normal flex duct or sheet metal ducting is sort of out of the spectrum of what we need. So small diameter equipment and small capacity heating and cooling is going to be needed. So if we look at the general industry trends, we're seeing overall, there's an increase in performance standards from not just the enclosure, but also from the space conditioning equipment. We all know that there's a lack of skilled labor on the market, and builders are challenged each day to try to build these homes as quickly as possible, and they're struggling trying to close these homes in their schedule. And the adoption of BIM technologies is becoming more apparent, especially with the large builders. So how to integrate these technologies in their architectural systems. But basically, these trends are very similar to the HVAC challenges that they're facing today. So in the HVAC industry, we're looking at the new influences of design integration into architecture. Traditionally, the trade contractor his priority is to install the system according to how he feels like it. They typically don't follow design. So design integration is important in the industry today. Installation quality has been very challenging, especially for production home builders, trying to install equipment, but also install ductwork that ensures comfort and ensures airflow to each of the rooms. And from commissioning consistency, the industry lacks commissioning. I think with some programs like Energy Star and other energy code programs, commissioning is a priority and is almost a requirement. So we're seeing a lack of commissioning. And then specification standards compliance, I think that one there is really the builder specifies the equipment, but we're not seeing that specification being installed in the field. So close eye is taken to ensure consistency and specification. And then from a new construction standpoint, standardization is really important to them. So today's level of design, quality, installation does not help the traditional builder create standardized methods and design protocols. And then what is the connected technology impact? We're starting to see connected technologies in smart thermostats, but we don't know what the forecast will be with connected technologies and how it'll affect space conditioning, but we believe it'll impact that technology significantly in the future. So from a traditional duct system, this is typical. We're seeing a lot of sheet metal and a lot of flex duct systems. In sheet metal, it's very labor intensive. It's basically pieces that come to site that have to be field fabricated and sometimes custom fabricated in a sheet metal shop. All these connections need to be airtight, so they have to basically install a lot more sealant, whether it's mastics or tapes that have to be installed, so there's a lot of time that gets incorporated into the installation. And then the design complexity. Larger ducts, it's harder to design and integrate into the architecture. And then there's just many parts and pieces that go into home that make up a duct system. So what's the advantages of plastic ducts? Well, so right now, we're looking at plastic ducts, but really small diameter plastic ducts. So when we look at the traditional flex duct and sheet metal, it's difficult to get those smaller diameters in size. Right now, sheet metal ducts can only go to a 4-inch diameter. Flex ducts, there are small diameter flex ducts, but they incorporate some problems in regard to installation flexibility and also kinking and also just the friction rate within the duct itself. So that's where we're looking at plastic ducts that have smooth walls, interior surface walls that provide less friction, that are ultimately airtight. We've tested plastic ducts that are not even welded, sealed, and they're very airtight. And they're easier to route than a larger diameter duct. And then the small diameter, looking at single size small diameter, helps with the design methodology of installing and designing these duct systems. So again, from some other aspects of designing with plastic ducts, again, easier to integrate. This picture that you're seeing here is our mock-up home in our warehouse that we had, open web floor joists, and you can see all the duct runs coming to a central location. where it's easier to route, and there, as you can see, there's a lot less components. One size for every room, and the elbows are very consistent, and it's easier to actually incorporate into the architecture of the home. And ultimately, it's a lower cost system.
Okay. Well, I'll pick it up here, and I want to get a little bit into how the codes are addressing ducts. Essentially, if you look at the IRC, it describes a duct system as really a continuous passageway for air from the space conditioning equipment to the various rooms in the house. When you talk about some of the performance requirements that are in the codes, and here looking at the IRC and the energy code, the IECC, we see that ducts are required to be insulated if they're outside of the conditioned space, the conditioned envelope. If they're inside the conditioned envelope, that requirement's not there. There is requirements in the code for duct air tightness and testing those ducts to measure the level of air tightness and ensure that the target levels are being achieved. Again, when ducts are located inside the conditioned envelope, some of those test requirements are no longer required. Within the code, there's a requirement to not use framing cavities for ducts and plenums. As well, there is a requirement that the equipment itself, the air handling equipment, is relatively airtight. So that's another requirement that you see in the residential and energy codes. And there's also requirements around fire performance, smoke performance of ducts in the codes, and that's where we really start to get to really what the goal and aim of the codes are, and that's to ensure the occupant's life safety within the building. And ultimately, what that means is that the home is going to sustain a certain amount of fire, certain amount of damage before collapsing, providing enough time for the occupants to get out, enough time for firefighters to come in and extinguish the fire. So when we look at the requirements related to that fire performance and flame performance with ductwork, we point to the standard, the UL 181 standard. Within UL 181, there are really two classes of ducts that are allowed, Class 0 and Class 1 ducts. Class 0 essentially are ducts and connectors that have no surface burning characteristics whatsoever of 0. Class 1 ducts do have a flame spread and smoke developed requirement. The flame spread index cannot exceed 25 and smoke developed index can't exceed 50. The testing that UL 181 requires is based on the ASTM E84 standard. So, based on that fundamental requirement of the code to protect the life of the occupants, there are some very specific characteristics that all ductwork rather requires. Now, when we start to look more closely in the code and look for other references, particularly around the use of plastic materials, there starts to reveal a little bit of ambiguity in the different code references. So when you look at the IRC in the mechanical section of the code, 1601.1.1, there's a reference in there that duct systems shall be constructed of materials having a flame spread index not greater than 200. So here we have a different flame spread index than is required under UL 181. Then if you go back to the class 1 air ducts, really what you see is a requirement that these ducts meet the 25 flame spread index and 50 smoke developed index, and are installed according to manufacturer's instructions. So there's a contradiction. If you look into another section of the IRC, this is the electrical section of the code. There is a section related to situations when cables are run through ductwork, and the requirements around the type of cables that are used, if they're sheathed in plastic, make reference to completely different testing requirements that don't correlate directly whatsoever to the UL 181 standard. So here we have 3 different references to plastic materials within and related to ductwork, and that creates a little bit of uncertainty and ambiguity around what that means. In 2005, the IRC issued a formal interpretation. Again, this is in reference to section, the mechanical section in the IRC 1601.1.1, where it does require the Class 0 or Class 1, that ducts have a Class 0 or Class 1 rating. However, one of the conditions of that code section allows that components of the duct system, not the duct itself, but those fittings that we talked about earlier, be constructed of materials that have a flame spread index not greater than 200. So again, here we have another apparent contradiction in the language that's allowed within the code. One other item to bring up here, when you look at components inside duct systems that are currently being installed today, what you find is there already are components that are plastic, and the rating or classification of those components are uncertain. So here we have, this is a drain pan underneath a cooling coil inside a furnace. And it's clearly made of plastic, but what we find here is that there's really no reference to UL 181 or any other classification on the component itself. And this is basically right next to the heat source. So we're trying to kind of hone in on to what exactly is the issue that we're dealing with when it comes to the classification of ducts, and where do plastic materials fall within that? Really, what's the basis for the requirements that are currently in the code? Okay, so at this point, these are really the ambiguities that we're looking at and that we're dealing with. And what we would like to see happen, kind of given these realities within the code, is to clarify the language for the use of plastic ducts and plastic materials for our distribution systems. One avenue, of course, would be to propose a code change and to get the code to be revised to clarify what requirements and that language around the use of plastic materials and plastic ducts. Where we are right now, the current code cycle, the 2018 code, we're past the opportunity to do that. So for a code change to occur, we would need to look ahead to the 2021 code development cycle, which really doesn't kick off for another couple of years. However, the sooner that we can resolve this ambiguity, the better, and there are opportunities to do that under section R 102.1 of the code, which basically allows jurisdictions to allow the use of alternate materials, designs, and methods of construction and equipment in buildings. So this is one avenue to explore, one avenue that I think we should address, because that is one way that we can solve this issue between now and when a code change could occur. So, so kind of going back to this whole issue of what's the aim and goal of the code, and that's to ensure the life safety of the occupants. To do that, we really, related to plastic ductwork, we really want to understand what is the fundamental issue and basis around why the requirements are what they are. What's the concern related to combustion? Is it a concern of, flame inside the duct system itself? Is it a concern with flame inside the house? So if it's flame inside of the duct system, then does the heat source, the type of heating equipment and source of that heat actually make a difference? Does it matter if it's electric resistance, as in an electric furnace, if it's heat pump electric heat, Does it matter if it's a gas furnace? Does that have any impact on, on the requirements to the duct system itself? And, would it make a difference if there was an automatic shutoff at the blower, something that could stop that heat source if there was a fire in the house? So that's one question. If there's a concern with flame inside the home, so outside of the duct system, then it raises the question about the use of plastic materials in homes in general. So there are lots of plastic materials that are allowed to be used inside of homes. Why would plastic ducts be any different than that? So trying to kind of understand the basis for the decisions and requirements, I think, is fundamental here and would help looking ahead to how we would resolve this issue. Getting a formal interpretation at some point around some of the other language and requirements in the code would be helpful, but ultimately we're going to need to kind of get the language, in our opinion, clear to address this. So I want to take a little bit of time to talk about some of the work that we've done to date. I'll talk a little bit about some of it, and Anthony will talk a little bit about it. And then from there, we're going to go in and look at kind of the road ahead and where we're going. So in 2014, IBICUS pulled together, also again funded by the Department of Energy's Building America program, a group of industry experts that included code officials, members of UL and others, to look at this exact same issue around ambiguity in the code on the use of plastic materials. The focus of that expert meeting really was, can we put together language for a code change proposal and get that code change implemented in what at that point was, we were entering the 2018 code development cycle. So there really were two proposals that came out of that meeting. One of them, the RM 3315, was ultimately withdrawn in favor of supporting the RM 3015 proposal. So the RM 3015, and I'll show you the language of that proposal in a moment, was initially approved by committee. Ultimately, in the last round of final round of voting, was denied. So that kind of leaves us back in many ways at square one on how we can approach this issue in the code. We do have a summary report available from that initial expert meeting if anyone's interested in that. The next effort was the current project that IBICUS is working on with DOE that Anthony will talk about in a moment, and that's a plug-and-play air delivery system. You saw one image already of one of the mock-ups we'd installed, and that's where we're really looking at how to use a certain type of duct system that relies on small diameter plastic ducts, but we'll get to that in a moment. I mentioned the language on the RM 3015 code change proposal, and this is really what it was focused on. It was focused on identifying or classifying PVC that was used for ducts around some of their loading properties and ASTM performance standards. This was really a baby step to start to move towards the allowance of plastic materials. As Anthony talked about, there are some inherent advantages to using plastic ductwork, and so we wanted to kind of take the steps towards that goal. Again, as I said, it was approved by committee action as submitted, but ultimately denied in final voting. All right, so moving ahead, Anthony's going to give you a little bit of information on our current DOE project, and then we'll kick it over to Pam to talk about some of the DOE resources that are available.
Sure. So part of the DOE work on plug-and-play ducts, we're looking to obviously look at plastic materials in the use of air distribution. And we were simply, the distinctive characteristic we're looking for is trying to enable a home run duct system, similar to models that are currently in the market, like the PEX plumbing system. So where manifold centrally located, and then you're distributing in regards to PEX, it's water, but in this case, we're distributing air from a central appliance and then sent directly to the rooms. So then we're looking to use off-the-shelf products that we can create a kit of parts with basically a less kit of parts that we can then use to design the system to effectively condition spaces in the room. And then the last part was utilizing the skilled tradesperson and home designers to understand what's a new way to look at the design methodology from a design aspect, but also looking at the tradesperson when he's installing that system according to this new design methodology. How simple can they do it in the field? And then we're just trying to understand with these characteristics, can we get reliable results in the field and in our testing? So simple, our goals are there's three sort of rules that we have. Does this system achieve better performance for the homeowner and also the builder itself from a comfort standpoint? Will we have a better economic cost performance? And then lastly, is the system just easier for the trade to install? If we can hit those 3 points, and if we can create a win-win-win situation, we believe this technology has some opportunities in the market to support some of the trends that I talked about early on in the presentation. So from the model that we're looking at is, so if we look at the impact of the plug-and-play system in the market, and if we look at the model that PEX went about getting market penetration in the late 80s to where they are today, it's very similar. They came with a disruptive technology in the market, bringing PEX material to replace CPVC and copper. So we're looking at a plastic material to replace air distribution systems. And if you look at where they come from in the last 20 years, they've got pretty much a market penetration of about 75%. So we're looking at that model as replicating that with plastic ducts. And if we look at air distribution systems today in the market, there's no one that really owns that market. So we feel there's a big opportunity for a manufacturer to potentially take this on and bring it to market with some high level of confidence. So when we look at just the performance of the air delivery system, so we actually have a lab home here in Pittsburgh that is an unoccupied home that we actually retrofitted, removed the traditional system, and installed a small diameter plastic duct system, and we monitored the performance of the system over a period of time. But we also did some modeling via modeling we're using computer models to understand the performance, where we can actually model many homes across the country in different climate zones. And basically what we've achieved is the amount of time that the plug-and-play system stayed within the room temperature deviation, so from room to thermostat, was a lot greater versus a similar flex duct system that is traditionally installed in the market. So we saw less deviation from the T-stat, and then also the temperature deviation was a lot smaller than the plug-and-play, with the plug-and-play than the flex duct system. So we're getting higher confidence levels of maintaining comfort in a smaller temperature band with the plug-and-play small diameter plastic system. And then lastly, from an economic standpoint, and this is probably one of the most important pieces from a builder and market penetration, we built a townhome, a framed townhome in our warehouse to mock up and understand the time and motion of this system. So we mocked up a traditional sheet metal with flex duct branches, and then we also mocked up a 2.5-inch PVC scenario, and then a third one being a 2-inch PVC. So we designed the system based on our new design methodology, and the design methodology is somewhat simple. It's one size duct, one size airflow, and the airflow is obviously dependent on the amount of elbows and the length of duct, and we've done a lot of benchtop testing to understand the airflows and friction rates when we extend the duct in length and add fittings. So the design methodology was in place for the last two systems with PVC. We laid it out and integrated into the flooring system, and then we had contractors install the system, both the traditional and the two plastic systems. And you can see here from a material cost, we're getting less cost from a material standpoint. If you look at the amount of components or SKUs each system has, we're looking at reducing from a traditional of 22 components down to 6 components. And then obviously the length of duct does increase with the small diameter because for some rooms we may need 2 runs instead of 1. So the length of duct increases, but the overall cost decreases. So we believe we have a cost advantage for looking at plastic duct materials. And then lastly, these costs that we've used for the off-the-shelf PVC products are obviously Schedule 40 type materials, which is thicker wall plastics, which we believe we don't need when we're talking about air distribution. Traditionally, Schedule 40 is used for plastic when it's under high levels of pressure. Well, with air distribution, it's a lot less, and we believe we can go down to Schedule 10 or 15, which would then significantly reduce the material cost of the system.
Okay, Pam, you want to talk about the DOE resources available for this?
Sure. Can you hear me?
Yeah.
Great. So just real quickly, gone over a lot of material, and I'm just going to give a brief overview of some resources Building America has, and mainly the Building America Solutions Center. If you're not familiar with it, I'll give you the website here on the next page. This is a screenshot of the main homepage to get into the Solutions Center. And really what this is all the Building America research teams that create all these great reports, some of them 100 pages long and so forth, and best practices, some of them get rewritten, some of them just get automatically put in, but they put them into this Building America Solutions Center in a really good format. So you can search on certain things, you can search from A to Z on guides, you can look at Energy Star provisions, Zero Energy Ready Home provisions, Indoor Air Plus, EPA Indoor Air Plus, all the different programs that are available. And there is one area in here that are code briefs. If you can go to the next slide. Code briefs were developed basically a couple years ago. There was a need to develop code briefs for technologies going to market that maybe were up against a code barrier. And I'll talk about code barriers, I think, on the next slide.
I think this is the slide.
That's fine.
Yep.
You're on the next slide. So, yep. And the way to get to these is there's about 35 code briefs that are in there. Some of them are basic code briefs that really tone down to make it really easy for a code official and for a builder to keep them both on the same playing field. All the code provisions for a certain technology or a certain provision, and then how to plan review to it and how to inspect to it, and then it puts in there some of the technical validation, all these nice reports that these Building America research teams have done. So this is kind of how you get to it. This is a screenshot. There's 2 ways. You can go down on the left-hand nav and click on code briefs, and it'll give you a list of them. And also in actual guides themselves, if you see up at the top left-hand side where it says Guides A to Z, there are hundreds of guides, the best practice guides within this tool. And if you happen to click on one, such as this one, the example of air sealing multifamily party walls, which had some certain barriers against code, which had to do with air leakage testing, that there'll be a button here that says Code Compliance Brief. And that Code Compliance Brief is what is really, it's like a code note. Building Codes program has code notes, and Building America has code briefs. They're similar if you're familiar with those. You can go to the next slide. And here's a list. If you click on the code briefs on the left-hand nav, it'll start giving you a list of all the code briefs that are available. We will have one, or going to start writing one, on the plastic ducts. And we're hoping that some of you that are on the call today, we'd love for you to peer review it, read it. Really, these code briefs are made for code officials. I mean, it's to help you, save you time during plan review, list out all the code sections, any issues there might be, with maybe a code barrier that there is, and how it can be overcome. How can you accept this technology? That's really what these code briefs are about. So you can go to the next page. So as I talk about this is what this effort's called. It's Codes and Standards Integration is really, it's a small task that Building America started a couple of years ago. And so what is a code barrier? And how do we define what a code barrier is for Building America? And if you look at a technology, does that technology or that code require the wrong thing? If you're looking at one specific technology, does it prohibit the technology, the code, or discourage it, or does it not even encourage it at all? A lot of them fall under a lot of the code briefs, and a lot of the technologies really don't fit the first one too well. Most of them are that they're just not in code. With this one, as Ari and them have talked about today, where there's that one ambiguity with the plastic ducts and the flame spread. So with the code briefs that we're going to develop, we will discuss that in more detail. And then how can you get around that, or how can a code official approve plastic ducts and get these out to market? You can go to the next slide. So with the code briefs, as I mentioned before, and you can go back to these slides as Ari sent them out to all of you as a reference. They're broken down and they're all the same format, where it'll give an intro to what is the technology, and then it'll go into how do you plan review to it with all the code sections of the IRC, IECC, could be the mechanical code, electrical code, plumbing code, whatever it might be that's involved with that specific technology. And then the last part of the code brief would be that technical validation, which is where you can go to the more substantial reports, any testing that's been done on that technology to actually back up that this technology is ready to go to market. That's all the technical validation is in these code briefs. And we can go to the next one. So with that said, here's a screenshot of one of the code briefs. And again, this one is on air sealing for party walls. And this one's a longer code brief because there was a lot involved with common walls in multifamily buildings. If you're interested in this topic, go take a look at it. I also would love feedback. So if you get into looking at some of these code briefs, please let me know. I oversee them. I write most of them. And Ibicus helps quite a bit with them as well. So please go take a look. This one has a success story with it. In Colorado, they reference this code brief quite a bit because they got a lot of multifamily buildings, and they're dealing with testing of each unit in multifamily buildings, and so they're up against this as far as a code barrier and meeting the new air leakage requirements or testing requirements in the 2015 and 2012 IECC. And with that said, I think I have one more slide. Again, this is the URL to get to the Solution Center. Pretty easy, besc.pnl.gov. There is also an interface, a nice simple interface with this tool where you can log in, you can actually register with a username and password, and you can start creating your own set of material that you want, that maybe you're out in the field and there are a lot of pictures, CAD drawings, and so forth that are in this tool that you might want to just capture and then have them on hand, like if you're out on site. Or maybe you want to train. If you're a trainer and you want to train in your building department, there's a lot of good material in here that you might want to put into your own interface or your own application. Is you can log in and you can go into your set of materials instead of having to go back and look through all the materials that are in the Solution Center. You can start capturing them and putting them into your own repository, so to speak. So with that said, that's just a quick overview, and I will turn it back over to Ari to finish up.
Great, thanks, Pam. Okay, so we do have some time left. I wanted to wrap up our presentation portion of this just with kind of our ask to you looking ahead. Big thing was to present this material to you today in this expert session. We've updated the slide deck a little bit since this was emailed out to you over the weekend, and so I will follow up and send this back out to everybody on the webinar with the updated slides. The big ask for you really is filling out this questionnaire, at least in the immediate term. As I mentioned earlier, as Anthony was talking about, we are wrapping up our current project with DOE, with the Building America program, on the initial development of the plug-and-play duct system, the design methodology, and some of the validation of its performance and cost and installation and that kind of thing. Getting your feedback on this specific issue around the use of plastic ducts is really critical in our mind to inform DOE on really what's the lay of the land out there. How are plastic ducts being perceived in homes? Are they even being perceived at all? So if you guys can take some time to fill out that questionnaire and get it back to us by January 24th, that's a week from today, that'll give us time to compile your responses for DOE. Certainly, if any one of you is interested in the collective response, we're happy to share that. We do respect, anonymity if that's what you prefer. But this issue is really an issue that affects the industry overall, and so we want to be able to accurately inform any solution that we move forward toward developing. So as Pam mentioned, she's working on a code brief related to this issue of plastic ductwork. She'll be working on that over the next 2-3 months. I know she would love to get any of your feedback, your peer review of that document and development, so that it can be most valuable to your community, to the code, to the code development, code official community, as well. As we look ahead to the 2021 code development cycle, if the decision is to move forward with a code change proposal around this issue, getting your further involvement in that moving forward would be, I think, absolutely vital, critical, and important to have. So, obviously, as much time as you want to put into any of these activities is great, but if you had just, some time set aside initially for the questionnaire, including, responding back a week from today, helping Pam in the development of her code brief, and then moving ahead, even looking toward the development of a code change proposal, we're expecting about 4 hours of your time to go to this effort. So it's not a lot, but certainly it's something. And if you guys are willing to help out, that'd be great. So we have about 15 minutes before the end of the session, and looks like we haven't received any typed in questions. So I think what might be great is to get anyone who wants to bring up a point. That could be a thought, that could be a question, to raise your hand. I think everybody sees the little hand icon on your GoToWebinar window, and we can unmute your microphone, and if you want to speak or ask any questions to the group, just share any thoughts, that now would be a great time to do that.
And we really want your feedback, meaning what was shown today, if you think first time coming in the door, if you were to see a duct design and they've given you all of the sizing, they've just done the sizing on the ducts, what are your thoughts? You've seen a lot of the details in the code sections. You've seen where there's a little bit of ambiguity between plastic ducts. We want to know what you think. And this could be fresh to you, learning it for the first time or seeing this for the first time. What would be your thoughts if you saw it come in your door? Anyone, talk. I'll start picking on some of them.
Yeah, and please, yes, speak. But there's also
on one person right now. Shirley, give me some thoughts. You work with a lot of code officials, and you work, real closely with ICC. I want to know what you're thinking about this.
Okay, we just sent you your PIN, Shirley, in case you do have some thoughts and want to chat. You'll just need to put your PIN in. She's currently muted. Anyone else you want to call on at the moment?
Call out.
Call out, I should say.
Okay.
Oh,
here comes Shirley.
Raise your hand. Okay. All right. Okay, Shirley, you need to put your audio PIN in so that you can speak and we can unmute you. Okay. Or conversely, that doesn't seem to be working at the moment. If you have any thoughts that you can type in, apologize for that. If you can type them into the chat function, we'll read your thoughts, not telepathically, but through the text function. If you have any and you want to type those in, that would be great in lieu of the audio.
And Shirley, while you're doing that, if you choose to do that, I'll just reiterate that the questionnaire that we sent around also is an opportunity for you guys to give feedback. We ask questions to try and hone in on, what are you seeing or what are you thinking right now related to plastic ducts? But if there's any other thoughts that you have, it's a Word document. You can enter those thoughts, and we can compile that information as well.
The other thing that we'll do.
I don't know.
I'm sorry, go ahead.
Go ahead. No, go ahead.
Oh, all I was going to say is the other thing, in case you're wondering if there's anything you want to go back and listen to, if there's anyone you want to share this with, we did record the session today, and we'll convert it as quickly as we can and get it up on the YouTube page and share that link with you as well.
Yeah.
So that you can take another look at it and see if there's anything that you missed or anything you wanted to point out to a colleague or something of that nature.
So you'll have the recording of the webinar, you'll have the slide deck, and the questionnaire. We're planning on wrapping up our reporting out to DOE this month, so at some point there will be a report available, I imagine, as well, that summarizes the results of this initial engagement.
And one more thought, we had a good turnout today, but if you know of other code officials, maybe in your department, I saw that Houston, there were a couple of you that signed on from Houston, but go ahead, please share the questionnaire. The more we have seeing this that we can get feedback on, the better. Or if you have someone that you want to send the names into, me or Ari or Anthony, that's fine too. We'll send it out to them and ask them if they'd like to participate, and we can give them a link to the video or the presentation. But yeah, the more the better. We sent this out to a few, but we don't want a large expert group, but
Right.
We want to make sure we hit as many co-officials around in each climate zone as possible to take a look at this and see the questionnaire and fill it out.
So Shirley gave you the thumbs up on what you said. She said what she heard sounded good. Good information. Didn't have anything other specific to add at the moment. Thanks for doing that, Shirley. But if you think of anything else, or if anybody else does, as they said, go ahead and send that information to them. I'm sure they'll follow up with you.
Yeah, and I guess one last thought, last week we were at an International Builders Show, and we presented plastic ducts to several builders there, and they were very intrigued by the performance of what we've achieved, and they're intrigued by the potential to bring ducts in conditioned space by utilizing small diameter plastic ducts. They understand the code challenges, but if we can overcome some of these code challenges, they would be more than happy to try this. Especially in California, where they're struggling trying to understand what that attic condition is going to look like, especially come 2020. So there's some good feedback we got from some of the big builders that we work with.
Yeah. So up on the screen is all three of our contact information. You can reach out to any one of us. Pam's a great resource when it comes to really any code issue. She has quite a good network out there, as I'm sure a lot of you already know. So if there are other issues that you guys are, facing in the code outside of this particular one, I still encourage you to contact Pam. She's a good resource for that. Yeah, and just to kind of confirm, we are going to send this slide deck back out to everybody so that you have it. We'll also resend the questionnaire out just to be sure everybody has a copy of it. And then, as we mentioned, we will convert this recording of the webinar itself and make that available through a link to a YouTube site where that recording will be. And as Pam said, please feel free to share this information with others. I think we reached out to all of you and appreciate your participating in this webinar. But if there are others you think would be able to offer some useful insight or be able to help steer or guide, this issue, whether it's to get, approval under alternate materials within a jurisdiction or toward a code change proposal, that could affect the code language overall, please feel free to share this information and get their input. Well, I think given we don't have any other people who want to speak up, which I appreciate. I never one to always want to volunteer, but I really am grateful that everybody stayed through to the end here. And I think we'll wrap it up now. You'll have our contact information later. If you need to reach back out, please feel free to do so. And again, thank all of you for participating in the session.
Thank you, everyone.
Thank you.
All right, take care.